we're going to go on and get started. Are there any questions over any of the assignments thus far? Any questions over any of the assignments thus far?
Hey, don't talk to my girlfriend.
Trey, you'll need to put the coat back on. Yep.
Man, that's 3 fingers. Inspection. More fingers. What? Oh, Simon was 3.
Yep. Shoulders. You got to cover the shoulders.
See, Simon was 3. Just one Christmas.
So,
Just break it.
any questions on, guys, any questions on any of the assignments thus far? All right. Let's go on and get started on the note sheet today. So what we're doing today, tomorrow, and Wednesday is covering solving. So we're going to be solving these rational equations. Now, the first one that we look at is this one here. We have 3 over x plus 1 is equal to 9 over 4x plus 5. Now, again, with any of these here, any of these rational equations, we will have restrictions, because the denominators for this here cannot be 0. We cannot have a value of x that will make the denominator 0. Now, the way that we can find these restrictions is, well, just setting the denominators equal to 0 and solving for what value of x would make them 0. So the first one we can look at is, well, x plus 1. Because we can set it equal to 0 and solve. Guys, so the first thing we can do here is subtract 1. Which will let us know that, well, x cannot be negative 1. Because if x is negative 1, it would cause the denominator to be 0. The other spot where we cannot have x being 0 is 4x plus 5. Because if the value of x makes this here, this 4x plus 5, 0, we would have another spot where the denominator would be 0. So the first thing we can do here is subtract 5 from both sides. And if we subtract 5 from both sides, the 5 and 5 would cancel, leaving us with 4x equals negative 5. And lastly, we can divide both sides by 4, telling me x cannot equal negative 5/4. So when we go about solving it, this here, if we get a solution of negative 1 or negative 5/4, we know that those two numbers, or that number, would not be a solution for this equation, and it would be something we'd call an extraneous solution. Because any solution is considered extraneous if we get it as an answer, but it does not work in the original problem. Any questions on this so far? So really, we did all this to really find out that x cannot be negative 1 or negative 5/4. Any questions on this here? Now, this here is just telling us what the values of x cannot be. So if we get a solution of one of these two, it's really telling us that actually doesn't work in the original problem. Because we cannot have a value of x as a solution that will also make one of the denominators be 0. Now we're actually going to go about solving it. Now last Friday, so last Friday when we worked on complex rational expressions, we had a method where we multiplied the top and bottom by a certain expression to be able to get the fractions to simplify. So we wouldn't have denominators in the numerator and denominator. Using a similar method here, what would I need to multiply 9 over 4x plus 5 by to get the fraction to simplify? Not quite, because here the denominator is. So if I multiply 9 over 4x plus 5 by 4x plus 5, well, the 4x plus 5 and 4x plus 5 would simplify. Now, the 3 over x plus 1, we would need to multiply it by x plus 1. Because the x plus 1 and x plus 1 would cancel. But what we do to one side, we have to do to the other. So we actually have to multiply the whole thing by 4x plus 5 and x plus 1. And the reason we're doing this is so that we can get rid of all the denominators. It's going to be easier to solve if we don't have two fractions. Now, when we do this multiplication here, on the left-hand side, we have 3 times x plus 1 times 4x plus 5 over our x plus 1. On the right, we'll have 9 times 4x plus 5 times x plus 1 over 4x plus 5. Now, when we look at this here, we do have things that simplify in the numerator and denominator. For the first one over here, the x plus 1 and x plus 1 simplify on top and bottom. On the other side, we have 4x plus 5 and 4x plus 5 that simplify. And when we do this simplification, what we end up getting is that we have 3 times 4x plus 5 is equal to 9 times x plus 1. So multiplying by this least common denominator actually simplifies both sides of the equation to where we don't have any fractions left. It makes it a lot easier to work with. Any questions on any of this here before we move on to the next step? Well, the next thing we need to do is actually distribute the 3 and 9 and then solve for the value of x. Well, if we distribute the 3, well, 3 times 4x is 12x, plus 3 times 5 is 15, is equal to, here 9 times x is 9x, plus 9 times 1 is 9. Now what can we do next? We can subtract 9x from both sides, yes. And if we subtract 9x from both sides, well, 12x minus 9x would be 3x, plus 15 is equal to 9. Then our next step would be to subtract the 15 from both sides, yes. And if we subtract 15 from both sides, well, 15 minus 15 is 0, leaving us with 3x is equal to negative 6. So last but not least, we can divide both sides by 3, telling us x is equal to negative 2. Negative 4. So we went on and solved and found that the value of x is negative 2. Is negative 2 one of our two restrictions? No. Because it's not negative 1 or negative 5/4, so that means that this is the correct answer. And that's all we have to do for these here. Any questions on any of these here so far? Now, if we wanted to check our answer of negative 2, we could do that by plugging it back into the original equation. So we have 3 over negative 2 plus 1, and we have 9 over 4 times negative 2 plus 5. And if both of these expressions give us the exact same answer, then we got the correct answer of negative 2. So for the first one here, well, negative 2 plus 1 is negative 1, and 3 divided by negative 1 is negative 3. For the other one, well, 4 times negative 2 is negative 8, plus 5. Well, negative 8 plus 5 is negative 3, and 9 divided by negative 3 is negative 3. Well, since we got the same answer for both sides, it means we did get the correct answer. So we can check it by plugging it back in and seeing if both expressions do give us the exact same thing. So the correct answer is negative 2. Any questions on any of this here? Any questions over anything we've done so far? Okay. We're ready for the next problem. So let's look at this one here. Now we can look at the restrictions to see what value of x we cannot have. And well, it's really whatever value is going to make either x plus 2 or 3x plus 2 be what? 0. We cannot have 0 in the denominator. So we can set x plus 2 equal to 0 and 3x plus 2 equal to 0 to see what values are going to work. Well, for this one here, we would subtract 2, letting us know that x cannot be negative 2. For the other one, we would subtract 2 first, which would tell us that 3x is equal to negative 2. Divide both sides by 3, which tells us x cannot be negative 2/3. Now, most likely, with all the problems that we'll be doing today, the restrictions won't show up as a solution. So, what do we need to do first in solving this here? Well, the first thing we need to do is get the fractions to simplify away, because if we can get rid of the denominators or simplify the denominators out, it'll make this easier to work with. So what can we do first in simplifying the denominators? Is we will need to multiply both sides by 3x plus 2. What else? X minus 2. We need both. Because the 3x plus 2 and x minus 2, when multiply both sides, or both of these terms, will simplify the denominators out. Because we don't have to rewrite it with the multiplication. We could go on and do the elimination here, that the x minus 2 and x minus 2 would cancel. Here, the 3x plus 2 and 3x plus 2 would cancel, leaving us with 2 times 3x plus 2 is equal to 10 times x minus 2. I rewrote it out the first time so that I could show that process of it simplifying out. And now that we see that and understand how that works, we don't have to rewrite it again. Any questions on how we got to this here? Okay, well now we need to distribute and solve for the value of x. Here 2 times 3x is, plus 2 times 2 is equal to 10 times x is 10x minus 20. 10 times 2 would be 20. Well, what can we do next? We can minus 6x from both sides. And when we subtract 6x from both sides, well, 6x minus 6x is 0. So we get 4 is equal to 10 minus 6x is 4x minus 20. Then what can we do next? We would add 20 to both sides. And if we add 20 to both sides, we get that 4x is equal to 24. And at this point here, we can divide both sides by 4, telling us that x is equal to 6. Any questions on this here? Well, is 6 one of our restrictions? No. So that means it'll work here in the problem. So if we were to plug it back into the original equations, we would get that both sides are the same. They both have the exact same value. Any other questions on this here? Okay. Guys. So let's look at this next one here. Now, if we're looking at the restrictions, we're wanting to see what is going to make the denominators 0. What value of x would make the denominator 0? Well, for 5x, it would be what? Zero.
How are you? Good.
So here it would be 0 because we have 5 times x. We don't have anything else there, so what times 5 would be 0? Well, 0. And for the other part, we have x minus 7. Well, what value of x would make x minus 7 0? 7, because 7 minus 7 is 0. Now, we could have also set those equal to 0 and solved and got the exact same thing. Any questions on how we got the restrictions of 0 and 7? No? So let's go on and solve. We have 3 over 5x is equal to 2 over x minus 7. So what do we need to multiply both sides by to get the denominators to simplify out? X minus 7, x minus 7. Anything else? 5x and 5x. Because if we multiply both sides by 5x times x minus 7, well, on the left-hand side, the 5x and 5x would cancel. On the right-hand side, the x minus 7 and x minus 7 would cancel. And now we just need to multiply what we have left, yes? So what are we multiplying the 3 by what? X minus 7, yes? What's 3 times x? Minus 3 times 7 is 21. So we could have written this as 3 times x minus 7 and then distributed the 3. Or if we feel comfortable enough, we could actually just go on and distribute the 3. We don't have to rewrite it. The other side is 2 times 5x, and 2 times 5x is 10x. Any questions on any of this here? Well, what can we do next? Well, we can subtract the 3x from both sides, because again, we're trying to solve for the value of x, get x by itself. 3x minus 3x is 0. So negative 21 is equal to 10 minus 3x is 7x. Last but not least, we need 2. Divide both sides by 7, telling us x is equal to negative 3. And that's all we need to do for this here. Any other questions on any of this here? Bless you. And is negative 3 one of our 2 restrictions that we had for this year? Well, no, so that is the correct answer. And if we plug negative 3 back in, we would see that both sides of this equation would give us the exact same thing. We would get the exact same thing on both sides. Any questions on any of this here? Any questions on anything we've done so far? No? We ready to look at the next type? Do we feel comfortable with these here? Where we got one on each side? All right. If we feel comfortable with these here, let's go on and look at this one here. Because this one's a little bit different because, well, we don't have an rational equation, a rational expression on either side of the equal sign. Because on one side I have 2, and on the other I have 1. Now on the first few that we've done so far, you probably noticed that it did say solving each rational expression or each rational equation by cross multiplication. As on the last one, well, yeah, on both of these here, they are talking about cross multiplying. And here it changes to using the least common denominator, LCD. Now, the reason that they changed this is because cross multiplication only works if we have one fraction on either side of the equal sign. Then we can do that. Here, because we have 2 on one side and 1 on the other, we can't actually do cross multiplying. The only way we'd be able to do it is if I could actually rewrite 5 over x plus 7 over 4 as a single fraction. But there's a better way to do that. And it's really looking at can I multiply all 3 of these by so that the denominators go away, that they simplify out. Well, looking at the 5 over x and 9 over x, what would I need to multiply those 2 by to get the denominator to simplify? Well, we need to multiply each one of those by what? We can do this here. Guys, heads up. Thank you. So, like we were doing with the other ones, we wanted to multiply each one of these by a certain term to get the denominator to go away. So if I look at 9 over x, what do I need to multiply it by so that the denominator simplifies? Well, we would need to multiply it by what? X. Because if we multiply it by x, the x in the numerator and denominator would simplify. But if I multiply it by one thing, I actually have to multiply it by everything. Well, that x would also simplify the 5 over x. The x in top and bottom would simplify. Is there anything else that we need? The 4. Because the 4 would simplify the denominator in our middle rational expression. So we would need to multiply all 3 terms by 4x. And if we do this here, well, our first one is going to be 5 times 4x over x plus 7 times 4x over 4 is equal to negative 9 times 4x over x. And what we're using here is the least common denominator, which is our least common multiple, but just mainly focus on the denominators of each one of these fractions. Now, when we multiply each one of these terms by 4x, the first one, well, it would do that. Here, the x and x would cancel. In the middle one, the 4 and 4 would cancel. And in the last one, the x and x would cancel here. And if we do this here, what we end up getting in the end is, in the first one, we would have 5 times 4, which is 20. Plus, in the middle, we're left with 7 times x is equal to negative 9 times 4 is 36. So multiplying everything by 4x, even though we have 3 of them, did simplify the denominators in every single one. Now, even though we do have 2 different places that there is an x, because there was an x in both of these spots, we only needed to multiply by 1x, because in either place, x was only to the first. There was only one of them. Now, at this point here, we just need to solve for the value of x. And the first thing we can do in solving for the value of x is to subtract 20 from both sides. And if we subtract 20 from both sides, well, 20 minus 20 is 0, leaving us with 7x is equal to 56. And last but not least, we would divide both sides by 7, which would tell us that x is equal to negative 8. And that's all we have to do for these here. Any questions on anything we've done so far? We ready for the next one? All right, let's look at this one here. Now, if we look at this one here, we do need to multiply each of these terms so that the denominators will simplify out, and it'll make it easier to solve. So what is something we need to know that we need to multiply each one of these terms by? X and x minus 5. We need to multiply each of these terms by x and x minus 5. And the reason we're doing that is because in the middle expression, well, the x minus 5 and x minus 5 would cancel out. So we don't have a denominator for the middle rational expression. We would also have that the x and x would cancel. And what that would leave us with is, in the first, we would have x times x minus 5. Minus, in the middle, we would have 8 times x is equal to 3 times x minus 5. And that's going to help us be able to solve this here, because now we don't have any denominators, we just have a single equation. We have no rational expressions left, so it makes it a little bit easier to work with. Now the next thing we can do is go on and distribute the x and distribute the 3, and then combine any like terms that appear. So we can do x times x, which gives us x squared. X times negative 5 is negative 5x. Minus 8x is equal to, here we have 3 times x, which is 3x, and 3 times negative 5 is negative 15. Now we do have 2 like terms, the negative 5x and negative 8x, and we can combine those. Well, negative 5x minus 8x is negative 13x, is equal to 3x minus 15. Okay, so we finished combining like terms. Now what do we need to do next? Unfortunately, at this point, we were not going to be able to use division. Now, the highest power that we have with the variable is 2. So that tells us that this is a quadratic. Whenever we deal with quadratic or any higher degree polynomial functions, we've got to get this thing equal to 0. We need it equal to 0. So we have to get everything on the same side of the equal sign. So the first thing we can do here is to subtract 3x from both sides, which will tell us that we have x squared minus 16x is equal to, those will cancel, negative 15. Well, it's still not equal to 0, so we can add 15 to both sides, which will tell us that x squared minus 16x plus 15 is equal to 0. Now that we have it equal to 0, we can solve this by factoring, or we can solve it using the quadratic formula. Which one do we want to use? The factoring? So we can have our two sets of parentheses set equal to 0. Now, since the third term 15 is positive, the signs are the same and they match the sign of the middle term, which would be negative. So we would have negative and negative. Now, the factors of x squared would be x and x, because those are the only factors of x squared. Now we need to find the factors of 15 that would work for this here. Well, our factors of 15 are 1 and 15, or 3 and 5. Which one do we want to use? Well, the ones that would be helpful are 1 and 15, because if we do multiply this back out, we would get a negative 16x for the middle term. So now that we've factored it, we do have x minus 1 times x minus 15. Anytime we have two or more things multiplied together equals 0, it means that one of these must be 0. So it's either saying that x minus 1 is 0, or x minus 15 is 0. One of these has to be 0. And at this point here, we just need to solve for the value of x. So we can add 1 to both sides here. Negative 1 plus 1 will cancel out, telling us x is equal to 1. And on the other side, we would add 15 to both sides. And if we add 15 to both sides, we would get that x is equal to 15. And if we went back and plugged these into the original equation, we would see that both of these here work. Both of these here are the solutions for this here. Any other questions on this here? Any questions on anything we've done today? Yes.
Is that one easier than the other one?
So is this one harder than which one?
The other one that is like the one that we, I don't know. That one or
The quadratic equation. Because if we did this from the quadratic equation, our quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is referring back to ax squared plus bx plus c. So in this one here, the value of a is 1, the value of b is negative 16, and the value of c is 15. So at this point here, we would plug these numbers into the equation. So we start off with negative b. Well, that'd be negative 16 plus or minus the square root of negative 16 squared minus 4 times a times c, which is 15, all over 2a. Now at this point here, we do need to simplify the different parts of this equation here. So the negative 16 is just going to give us a positive 16. Now at this point here, I would plug everything, well, if it would give me a highlighter, everything that's inside of here into a calculator. I wouldn't use the square root just in case we get a decimal answer. And 16 squared, 96. So 256 would be 15 squared. Minus 4 times 15 is 60 over 2. 16 plus or minus the square root of 196 over 2. Well, it actually works out that the square root of 196 is 14. Now we're almost finished with this here. We do need to add and subtract because since we can add 16 and 14 and we can subtract them, we do need to do that. So we can say 16 plus 14 over 2 and 16 minus 14 over 2. Well, 16 plus 14 is 30, and if we divide it by 2, we get 15. And 16 minus 14 is 2, and 2 divided by 2 is 1. So we get the exact same thing. So if you can see the factors pretty easily, it might be easier to factor it. But if it's a little bit difficult to see, or if it doesn't factor, we'll have to go back to the quadratic formula. But most of these steps we could have done in the calculator themselves. But if there are no other questions on this here, the rest of these are actually the exact same thing. So we are finished with 7.51.